So, hello everyone, folks and friends. Hope you guys are doing great and thank you for attending this session. This is quite some journey that we have had in LR where we have discussed, give or take, at least about 20 different types of caselets, right? Is there a limit to what we can do in LR? Of course not. We cannot draw a limit. LR is limitless, which also means that in the exam, what comes may not exactly be what we've done, right? But the idea was to create some kind of a thinking in the minds of you guys. And that's exactly what should be happening when we are talking of this topic called LR and data interpretation, right? Over the years, we've seen that even though, right, CAT has gone, a journey of more than 30 years, but they have been able to get newer and newer variety of caselets, which means you should be ready to take on any type of question that comes in the examination. So for all that you need is uh, a level-headedness in the examination, and that's it. That's all you need in the LR. And like I otherwise say, if that does not work, you'll start using answer options, and finally, if that does not work, you just start, randomly taking easy values and substituting in short answer type. But we'll not even go to the type 2 or the case 3. It'll always work in the case 1, provided you guys have already started preparing and you guys are right there. Alright, so we'll first of all thank you for watching this, and let's quickly or straight away go to a question. Right, let's go to a question. Right, so the question is here. Right, let's quickly. I'll give you about a minute's time to read it. So you also would want to see the questions. Who is the shortest of them all when arranged in ascending order of fairness and descending order of height? There's one person who has the same rank in either attributes, who may be that person, and ranks are given 1 to 6, then what's happening, and so on and so forth. A pretty easy question. I'll give you about, let's say about 60 seconds or a minute to answer or to read this question, right? So go ahead. Okay, that's almost a minute. Okay, all good. We should start. Let's together read it and then we can start doing the question. A is fairer than B but shorter than F. There are 6 persons. Okay, there are 6 persons A, B, C, D, E, and F. Assuming the starting letter of the names are these. That's nice. They've not given the names. Sometimes in the examination they might end up giving names like Amar, Akbar, Anthony, Alfred, and Anamika, and that's when it gets tricky. When we have the names as distinct letters, that makes life so much so easier, right? So that makes a lot of sense here. They've given 6 persons. That's nice, right? Have certain following attributes are there. So let's see what these attributes are divided into 2 categories. One is fairness, right? And second is height, right? So if you're talking of height, let's say we have 1, 2, 3, 4, 5, and 6. 6 being the tallest and 1 being the shortest, right? And fairness scale, let's say we have A, B, C, D, E, and F. F being the fairest of them all, and A being the least fair of them all. So we can push it in this order, right? So if you're talking of fairness, right, versus height, there's certain clues given, right? And with that clue, we'll have to decipher, right, who is the tallest and who is the second tallest and who is the fairest and the second fairest and so on and so forth, ascending, descending, or something, some order that could come, right? Pretty simple question, right? At the end of this question, I'll be talking about, where you'd be able to see questions of this type, which book you can look up to see questions of this type, right? So they say A is fairer than B. So if I say A is fairer than B, that means B is darker than A. So I'll put that, less than sign, right? In no way it means that B is lesser than A. It just means B is darker than A, right? So A is fairer than B, but A is shorter than F. So F is taller than A, or greater than. In this case, I've represented it that way, right? C is darker than D. So we have C being darker than D. That's the next statement, right? But taller than A. So C is taller than A and F is also taller than A. Right? There's two statements that we got. B is fairer than E. Ah, that's nice. B is fairer than E. We can put it in one particular inequality itself. B is fairer than E, but B is taller than F. B is taller than F. Okay, super. Makes sense, right? B is fairer than E. That's what we marked here. And B is taller than F. F is fairer than A. So we have F being fairer than A. Okay, we can put that here. Pretty easy. F is fairer than A. F is fairer than A, but F is taller. F is taller than C. Okay. F is taller than C. So that means C should come somewhere here, right? Between A and F. F is taller than C, right? Okay, somewhere between A and F would be the value, we could place the person C. E is fairer than C, right? E is fairer than C, but they also say that E is shorter than C. So E is shorter than C. E is shorter than C. So what have you noticed, right? We have noticed that, we have B, then we have F, we have C, right? And below C, it could be A and E. We don't know in which order. Okay, let's look at the last statement. That's the sixth statement. D is darker than E, right? D is darker than E. But then that we know D is fairer than C, so that automatically means because D is darker than E, after E, D is darker than E. So after E, we should place D, and then we know that C would be the darkest, something like this. And then we know in the beginning, in the fairness scale, that's A and F, or F A B E D C. That's the descending order, right? So we can place the fairness scale. That's pretty easy. We have F being the fairest of them all. A next, followed by B. We have E. We have a D, and finally we have a C. That's a fairness scale. That's pretty simple. But the last statement says D is darker than E, but D is also shorter. D is also shorter than E. Now this throws up a lot of cases here, right? But we know for sure that B would be the tallest, followed by F, and then we have C. Now what happens after that? If we take the rank 1, 2, and 3, or the shortest, right? The second shortest and the third shortest, right? Now we are looking at these three guys, D, A, and E, right? We could place A at position 3, and we can have a D and E. We cannot have an E at position 2, position 1, right, and D at position 2, because we know that D is shorter than E, right? But then the position of A could change. We could have A at position 2. We could also have A at position 3 because invariably we know that A is only shorter than C. There's nothing between D and E that we can decipher here. But then in the case number, we had the case number 1, the first case, the second case, and the third case. In the case 1, we have like the shortest is D followed by E followed by A. Next one we have D, then we have A, and we could have a E. And here we can have the shortest, that is A followed by D and then E, right? That's how it is. That means 3 different cases that we can pull here. Very simple, does not take time to solve questions like this. Let's now look up to what's happening, right? Quickly, let's look up for the questions, right? We know that we have a height order, right? So the first question, who is the shortest of them all? So you guys got it. The question is simple. This part, the fairness scale, it is easy to map. The height, there's a little bit of confusion because the 3 is not given, but then we can pull out these 3 cases, right? Okay, so this is what is going to happen in the examination. Pretty simple stuff, right? Who is the shortest of them all? So if you're talking of the shortest, right, that means height of 1. Can we find out? It could either be D or A. We cannot actually sit and find the answer, so the answers cannot be determined, right? When arranged in ascending order of fairness, right? When arranged in ascending order of fairness and descending order of height. Ascending order of fairness, right? Ascending order of fairness, that's this, right? This is ascending order of fairness, right? C, D, E, B, A, F, and descending order of their height. So descending order of their height, if we take that, right, we'll have B, we'll have F, then we'll have C, and then we have the confusion, right? This could be a D and or an A, it could be a D or an A or an E, and this could be a A or E. So we don't know, right? Descending order of their heights, this is the height case, and the fairness is already there, right? Then what are they asking? Then who has a rank? There is a person who has the same rank in either attributes. Who may that person be? And they say, okay, there is one person who is having the same attributes, right? There is one person who has the same attributes, right? Who could be that person, right? Okay, so you look, say same ranking, okay? B does not have the same ranking, nor does F and D, nor does C and E in the position number 3. Position number 4, again, we don't have, but look at the position number 5, right? That's corresponding to this. We have an A here, again, there's an A here. There's no other place where we have the same thing, right? Twice. We have nowhere where we can account for this. So that means A is the person in context that we are looking for. If the ranks are given from 1 to 6 after arranging these people in descending order of height, 1 to 6, right? Descending order of their height, right? So 1 would be like this. Okay, this would be 1, this would be 2, 3, 4, 5, 6. That's your descending order of heights. That's pretty simple, right? And fairness as well. So if you're talking of fairness, nothing will change. If you're talking of fairness, right, 1 corresponds to descending order. Since we're talking, that would be F A, F A B, E D and C. Well. Okay, that's a fairness, right? Then what's the question? The question is, then the corresponding ranks are added. Who has the highest total? Now, if you're talking of, let's take one by one. So we have these 6 persons. A, let's start with A, right? A has a rank 2 here, while in the other case, A can have a 4 or 5 or 6. Now we don't know what's A. So it could be a 2 plus 4, which is 6, right? It could be a 2 plus 5, which is 7, or 2 plus 6, that is 8. So A can have varied ranks, while B will have only a 1 plus 2. You notice here, B has a 1 and B has a 3. 1 plus 3. That makes it 4. Very small number. We want a significantly large number, right? We're looking at C next. C has a rank of 3 here, right? Well, C has a rank of 6 here. That makes it 9. Okay, pretty much. Now it's the highest. C is the highest among these 3 of them. But what about D? D has a rank of 5 here, right? And D has a rank of either 4 or 5. So 5 plus 4, that makes it 9, or 5 plus 5, that makes it 10. So D could have either a 9 or a 10. Let's look at E. E has a rank of 4 here, while E could have a rank of 5, and E could also have a rank of what can we say? E could also have a rank of 6, right? E has a rank of 4 here, while E can have a rank of 5 or E can have a rank of 6. So what are we talking about, right? We are talking about E, that is 4 plus 5, which is 9, and 4 plus 6, that is 9 or 10, right? And F has 2 in one place, right? Second rank in one particular place, and first rank in the other place. That means a total of 3. So we are looking for the, right? What's the question, right? Who can possibly have the highest possible rank, right? So we are in confusion between D and E, right? We're in a confusion between D and E. Let's just check what we are doing, right? So D had, oh, okay, D had 5. D had 5 plus 4, that's 9. 5 plus 5, that is 10. Okay, and what about E? E can have a 6 or 5 plus 4. So 6, oh, okay, so that's like, 6 plus 4, that's 10. And 6 plus 4, that's 10, or 5 plus 4, that's 9. Yeah, okay, that's okay, right? Mhm. So I think that's what we were trying to place here, right? E, E, D, C. Fine, good, right? So we were trying to find out among the 4 of them, or 5 of them, whoever, the A, B, C, D. So they've given A, B, C, D, and E. A, B, C, D, E. So the question being, right? Who has the highest total? We have A, B, C, D, and E, right? Who has the highest total among all of them, right? Who has the highest total among these guys? Okay, let's check. Who has the highest total among these guys? So the highest total, as you've noticed, is obviously going to, highest total is going to, you know, E or D, right? That's what we've done, right?
Press the bell icon on the YouTube app and never miss another update.
Right, so coming back to the question, that's pretty simple. If the ranks are arranged in ascending order, you would notice, right? So sometime back, I had written for D as, rank number 4 or 5 in terms of height, but it could be 6 as well. So the answer is automatically going to be D, right? That makes sense, huh? Superb. So let's move to the next question. And what I'll do is let's try to do this together. Let's try to do this together. I think because it's a simple question, okay, or probably you can take a minute, right? Just look up this data and I'll look up the questions one by one. See how many Nair mixtures grinders, but then let's do it together first, and you can read the questions. You can do it together. You can do it by yourself, right? I'll give about 60 seconds. Simple one, old cat question, right? Very nice, interesting one. Purana and Nair are two brands of kitchen mixer grinders available in the local market. Purana is an old brand that was introduced. The names itself suggest Purana should be old and Nair should be new. Introduced in 1990, while Nair was introduced in 1997. For both these brands, 20% of the mixer grinders bought. 20% of the mixer grinders bought uh, in a particular year are disposed of as junk. Exactly 2 years later, it is known that 10 Purana mixer grinders were disposed of in 1997. The following figures show the number of Purana and Nair mixer grinders in operation from 95 to 2000, right? As at the end of the year, right? So that's the data, pretty simple graph, and you can read. You take about, let's say, you take about 60 seconds. Okay, let's say 90 seconds. I'm guessing you guys will be able to solve the question in the given time, not just go through, right? Okay, so that's almost there. The 90 seconds. Shall we start again? Okay, good. Simple question, old cat question, right? So, how many Nair mixer grinders were purchased in 1999? So, the good thing here is that the Nair just started in the year 97. That's the first year. But Purana started somewhere in the year 1990. So we don't know the data for the first 5 years. That's something to worry about in this question, right? We have no clarity on the data in the first 5 years. So let's look at the Nair data. In the year 97, right, we are talking of 30 Nair. That's the first thing. So I'll put box to represent the new, mixer grinders that were there, right? Uh, that were there in the market, 30. But then they say that 20% of them, right, 20% of them were disposed of exactly 2 years later, right? 20% of them were disposed exactly 2 years later. That means out of this 30, about we are talking of a number like six. The six of them would be thrown out in the year 1999. That means from this 30 will bring down the value of 24 here, and this 24 will come down to a value of 30 here. Sorry, and that will come to 24 because 6 will be thrown off after 2 years, not 1 year. It's after 2 years, right? That it becomes less, right? That means 6 would be thrown off here. Okay, so that's how the data is working for us. That's how the data is working for us. So that's 30 remains 30. Next year it becomes 24, right? Because it gets disposed, right? But then if you look at the year 98, out of the 80, we first 30 we fixed that. In the year 98, the 80 mixer grinders in the market. Out of the 80, 30 were old. That means they were fresh ones that were purchased. It's like 50 of them, right? But out of the 50, we are talking of 20%. So 20% of 50, that would be like 10. That would be disposed, of course, but 2 years later. That means in the year 2000, right? So out of this 50, all the 50 will draw to the next year. But in the next to next year, it will not remain 50. It will just become 40 of them because 10 of them will get disposed, right? But if you look at the year 1999, we need a total 124. That's the number we are talking about. But out of that, 24 is done, 50 is done. We need something. Here, 24, 50, all that is done. We need 74 plus some number should give us a 24. We're simply talking about a number called 50. The 50, 50, 24, that's 124. And this the sequence goes, right? So that means from here, from this path, okay, we had the 30, 30, 24, right? That data will remain like 24 here. Let me just rub that for a while, right? I think we'll get a little more neat, right? So that 24 will remain here pretty much. Out of the 50, this 50 was here, this 50 was here. This should become like 40, and this 50 will remain 50. But a total looks like 134. So if you add up those values, if you add up those values, with 50, 40, that is 90. 90 plus 24, that is 114. That automatically means there are 20 new ones that were purchased in the year 2000. Right? Are we making sense here? Right? I hope we are all making sense. The 6 were disposed in the year 1999, and 2000 there were 10 of them disposed. This disposed 10, right? The 6 were disposed because of this, and the 10 were disposed because of the year 1998. For 97, right, in 99 they were disposed in 20%. That's 6. At year 99 they disposed 20%. That is 10 from the year 98, right? So that's our data. Very easy to answer the first two questions. How many Nair mixture grinders were purchased in the year 1999? Right, we can clearly see the box represents, here we have represented the box to represent the new ones, right, in 1999. What are we talking about, right? So we just saw that data. In the year 99 they purchased 50 of them. This was 30 of them. This was 50 of them, right? This is another 50 of them, and this is 20 of them, right? The rest of the data we just saw. There were 6 disposed here, there were 10 disposed here, right? So there were 50 of them were purchased in the year 99. How many Nair mixtures were disposed? So we know 6 were disposed here, 10 were disposed here. The total is 16. So that's the kind of data that we have. Now let's look at the second question, and that's intriguing. That's interesting as well. How many Purana mixer grinders were disposed of in the year 2000? Now, if you look up the data, they say that 10 Purana mixer grinders were disposed of in the year 97. 10 were disposed in the year 97, right? 10 were disposed in the year 97. If you're talking of 10 being disposed in the year 97, so how do we map it? How do we map it? Right? 10 were disposed in the year 97. Okay? 10 were disposed in the year 97. So what are we talking about? So first, let's start with for 97, why there were 10 disposed? The 10 were disposed probably because in the year 95, there were 50 of these, right? So there were 10 disposed, that automatically means, right, that 20%, so that's the reason we came to 50, right? 20% of 50 is 10. So they were disposed in the year 97 because there were 50 new and the old ones were 70. I'm not saying it is from the previous year, it could be from previous several years, right? But that automatically means that in this 50 would bring down a value of, 40 here, right? 40 here. In the previous year, we have a total of 162. That is between new and old. Let me put new in a box, old in a circle. The total happens to be 162. The next year, the total, right, should have been how much, right? It's not 182 because 10 was disposed. The total should have been 192, but the 10 got disposed, right? That instead of 162, it should have been 192, but 10 was disposed. That means 30 new were taken here, right? 30 new were taken here, 30 new were taken here, and then 6 of them, from this, that is 20%. In the year 1999, 6 of them were again disposed. But again for the year 1996, right, to 1998, we have absolutely no clarity on the data. We have absolutely no clarity on the data, right? This is just 222. How the split is, we don't know. How the split is, we have absolutely no clue. We have absolutely no clue on this, right? So that's how the data is. So let's see what we should do and what we should not do, right? What we should do and what we should not do. We'll just go to the next one, right? That is here. That's in the year 1999. So in the year 1990, this 222, or the previous year, is becoming 236. But is it really 236? No, this number, like here, we are talking of this number should have been 192. It became 182. It became 182 for the simple reason that 10 were disposed. Likewise, it shouldn't have been 236 in the year 99. There were 6 more. So we are talking of 236 plus 6, that's equal to 242. But the number looks 236 because 6 were disposed, right? Which means that 242 is what the number we should be looking at. That means 20 new ones were added and the remaining, whatever the numbers are, they were old ones, right? They were old ones, right? That we're trying to fix in the system. That means 216 old ones that are there, right? And that's all. I think this year again 2000 we cannot do anything with it. The total is 236, and that clears the data. That clears the entire data for us, right? Okay, super good. So now let's look at how do we answer. How many Naya mixer grinders, how many Purana mixer grinders were disposed of in the year 2000? So we have absolutely no idea because all the even number years, you notice here, here and here, that's the year 96, 98 and 2000. We have absolutely no idea about what's happening, right? Question number 4, right? Question number 4, they say, how many Purana mixer grinders were purchased in the year 99? Now that's good. We know that data. That's 20 of them were purchased in the year 99. Right? That makes sense. Right? Pretty easy data for us to work with this question. Right? So that's nice. We'll go ahead and try to solve another question. Very simple one. Right? The intriguing part will only be this. Otherwise, everything is very simple in this question. Easy to do. Right? And it's common cat. So you see, the logical part is right here. Otherwise, it's the question number 3. Right? Otherwise, there's nothing much in this question. So CAT never focuses on difficult questions like I always maintain. It only focuses on little logical question or easy ones. Right? So let's move ahead to the next question. What say? All of you good? Are we doing good on this? Super. Let's move on to the next question. Right? Okay. So this is something different. I thought let's play something on your algorithm based questions. I will give you about 90 seconds, so you go ahead, solve it completely. Alright, so your 90 seconds are up, more than 90 seconds actually. Right, so let's start with this question. What's the answer for the first one? What do you think the answer is, right? Simple one, easy one. It can get more complex algorithms, right? This algorithm is an easy one, right? Let's look at how to go ahead with this one, right? So we have some few things to work with, right? Let me just change the color of the ink. Okay, so we have something called the value of x, then we have a value of y, and then we could try to fix the value of z, right? So initially x takes the value of 1, and but then what happens immediately is x is assigned as 1 plus 1, that will become 2. So y is x squared, that will become 4, and z is y plus x plus 1, that will become 7, right? So then it will ask a question, is z greater than 100? That means is 7 greater than 100? No, so it pushes this way. If it was greater than 100, it will come here and it will print the value of z, and it will stop the program. So if you now when x goes back to this place, it finds that it is 2, but then it will assign itself 2 is equal, I mean, it will take the value x, that is 2 plus 1, that will become 3, right? X will become 3, y will become 9, and z will become 13. And then if we take 4, x will become 16, and this will become 21. Now, you really don't have to do anything more. Actually, by now, most of you have started noticing, right? What is 7 plus 13? That is 6. What is 13 plus 21? That is 8. So here, for sure, the value addition should be 10. You can just check it up, okay? So if you take next 5, this will be 25. 5 plus 25 plus 1, that is 31. And this will automatically keep increasing. That means the next number should be plus 12, right? That means this should be 43, right? 12 plus 14, that will become 57, right? Plus what's this value? We're talking plus 16, that is 73. 73 plus 18, 73 plus 18, that's equal to 91, and 91 plus 20, that is 111, right? So when will it be 111? And that's the value where it will stop, right? If you take this is 10, so it become 10 square, 100, right? And 111. Okay. What's the maximum value that x can take? What's the maximum value that x can take? So the maximum value that x could take is 10 here. That's pretty simple. Which of the following is not a possible value of z? You'll notice that z values are always odd numbers, right? Because you're adding an odd number plus an even number. So we know odd plus even will certainly give us an odd number, right? So it cannot be b. Otherwise, it could be anything among these numbers, right? We have checked. But then you'll also notice in this question there's a little problem. It cannot be 67 as well, right? Okay, 67 is not represented in any of these cases here, right? Okay, so it should not be 67, nor should it be 72. 72 is out because it's an even number, and 67 is also not there. If z had been y minus x plus 1, now you'll notice something different here, right? So y, if you're talking of the first, if x is 2, then y minus x plus 1, that will become 3. But then 9 minus 3 plus 1 would become 7. And likely this is 13. You'll notice the increase is 4, then the increase is 6. All you have to do is keep coming, and when this value becomes 11, right, this value will become 111. When this value is 10, this value will become 91. This is just that this series is going to be written right here. That's all. That's how the case is going to be solved, right? If z has been y minus x plus 1, then what will be the print value of z? Of course, it will be 111, right? You notice how both the series are pretty much the same, only that in one case the series started a number ahead, in the other case the series started a number behind. Okay, and that's all. I think we have the last one in this question. What the value of z is always what? The value of z is always odd, right? Does it solve the case? Right? Simple one. I think we got to go to the next question. It's very simple, but now guys, now just think. Now this could get complicated. Oh yeah, I wanted to tell you some kind of data in the first question, right? In the first question, I was talking about a book, right? This kind of question is there in a book called Great Book of Puzzles and Teasers, right, by George J. Summers, right? That's a seminal work on the logical reasoning. You will not have time, but that book is way too advanced for the cat level. It's way too advanced for the cat level. But something that you guys might want to check, right, in case you are free, and I'm guessing you guys will get free in some time, for the reason that right now you should not be preparing. Right now you should be consolidating whatever you know. That's how the exam should be working. You should be working with the exam, right? So that's exactly what I would like to say.
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free AMC.